There are a lot of projects out there that require some basic soldering skills, joining of wires and such like that, including things like working on electronics, cars, boats, boat trailers, solar projects where you want a nice, good, low resistance connection. You want it waterproof, you want it mechanically sound. Other things include drip systems and things like low voltage yard lighting. Soldering's not difficult. I've been doing it since I was 5 years old. I've learned a lot from books and from experience. Let me show you some of those things. Today I'm going to be working with this bigger soldering gun, mostly because it's easier for you to see. I can use bigger wires and I can use this bigger tip, and it's a lot easier to see. But the same rules will apply to the smaller soldering guns, soldering pencils. The first thing to good soldering is to have rosin core solder. This is a non-corrosive. That's rosin core solder. It's a 6040 tin lead. That's pretty standard, but again, never ever use acid core solder or acid core flux on anything electric or electronic, because it will get into the works and it will corrode things away for years to come. So rosin core solder, non-corrosive. The main secret of good soldering is clean. Starting with a good clean tip on your soldering iron, having good clean work, and this is absolutely wrong. You do not want to try to solder stuff like that. You want clean, shiny, copper colored work. And one thing that people don't talk about is you want clean solder. You can see down here, this is kind of grayish looking, and up here it's more shiny. This has been sitting around a while and it's picked up oxide. Oil is the absolute worst thing. Oil from dirty hands like these gets on your solder, and oil will ruin a solder joint faster than anything. So good, clean solder. Before you begin, dampen your sponge. Definitely use a sponge. If you don't have a sponge, use a wet paper towel, something like that. Don't sling your solder around. Use this to clean your tip. Solder's toxic. Slinging it around is a bad idea. Clean your solder. Wipe it off. Make sure there's no oil or grease or anything on it. Make sure there's no oxide layer on it. Clean solder is also important. There are 4 steps to good soldering, and the first one is to have a good, clean joint. You want it mechanically sound and you want it clean, and you can see right here, this is not clean. So I'm going to go and cut that out of there and re-prepare this, and I'll be right back. We have our good, clean joint. Now we want to make it mechanically sound. We're just going to twist it together. You can use pliers if you need to. This is a kind of a stout wire, so we'll do just that. Twist it together. And there we are. You want it stout enough that it will not come apart while you're soldering it. The second step is to have a clean soldering tip. Clean it off on a sponge, get it nice and shiny. If it's not shiny, throw some additional solder on there. Let me go over the third and fourth steps before I do them, because they happen rather quickly together. The third step is to press the soldering iron onto the work as firmly as possible, and to wet the tip a little bit with some solder. This solder is not meant to start the soldering process. What it's meant to do is help transfer the heat. It's to wet the tip to transfer heat better from the soldering iron down to the workpiece. And then the fourth step is to apply heat and apply solder to the work. You want to apply solder to the work. If you apply solder to the tip, it will burn the flux away before it's had time to do the job with the copper. And then you move these two together, and when you're done, lift it away and do not touch the piece until it's had time to cool off. If you move a joint while it's still wet, while the solder is still liquid, the joint will be a cold joint. It will not be a strong joint. So here we go. Touch the soldering iron on here, add a little piece of solder to help wet the tip and help transfer heat. And then I'm going to move the soldering iron along the work, along with the solder, and that's it. Now I'm going to let it sit until it cools. So let's inspect our joint. It's shiny, the lead is consistent, it is soaked into the wire, and it's consistent all the way around. So it's a good, clean, mechanically and electrically sound joint. Trimmed off the edge, make sure there's no sharp points, and it's ready to tape or shrink wrap or whatever you're going to do to finish it out. Let's try soldering some wires that aren't clean, see what happens. See how the solder just balls up on there? Doesn't want to try to stick to it. As I move along, see that? It's not doing anything. Doesn't want to stick. If I apply enough flux, sooner or later the flux will eat through it, but that's not. It's not going to make a good joint. Let's look at what we just did. That's a very weak joint. You notice it didn't even really bond to the second wire. And yeah, with enough flux you can eat through the coating on the wire, the corrosion coating, but it's a huge waste of solder, it's a huge waste of time, and you usually end up with a bad joint like this one. And before you put all your soldering stuff away, you should notice that this is a piece of solder, and if you look at the end of it, there's a hole in it. And solder is actually a tube, and in the center of it is that flux we talk about. And before you put your solder away, pinch the end of it so the flux doesn't leak out while it's sitting. Otherwise you'll end up with a roll of ruined solder. Let's talk about some minimal basic safety requirements when soldering. First of all, solder contains lead. Lead is a neurotoxin. It's not good stuff. If you solder occasionally, it's not considered high risk, but if you do a lot of soldering, you should definitely look into some very serious safety precautions. Again, these are the basics for home soldering and hobby soldering. So, you never want to use this type of solder for food, repairing cups, cooking utensils, anything like that, because it does contain lead. It will get into there. You always want to solder where there's good airflow. The fumes are bad for you. I've got a fan over here. I've got a ceiling fan up here blowing down on me. You never ever want to. Everybody says flip off the excess solder. When you get too much solder, just flip it off of there, and that's a really bad idea. First of all, it leaves solder droplets around like this. Pets can find that shiny little piece of metal and pick it up, put it in their mouth, whatever. It's not good. Also, if you scatter solder around a house or a work area, you can end up with lead contamination, and that's really hard to remediate, and you can find that selling the property becomes really difficult if you've got a lot of lead contamination, so don't do that. If you need to get rid of excess lead, what I suggest is just a quick touch to your sponge, or you can make one of these, a soldering tray, and you can flip it into there and you can recycle the solder. Along those same lines, keep your hands clean. You don't want to transfer lead from your solder while you're touching your solder in your work area into your mouth, eyes, whatever. Soldering is at high temperature. This is liquid. When you've got the solder on here, it's liquid lead. Liquid lead is the same stuff they used to pour over castle walls onto the invaders to kill them. And there's no burn like a solder burn. I can attest to that right there. That's 15 years old. And it really hurts, and when solder drops on your skin, it sticks there. It doesn't like to come off. So because of the high temperature, everybody around should be wearing goggles to keep hot soldering iron tips, anything like that from damaging eyes. You want to work on a fire retardant surface like this piece of metal I've got down here. I've got a stone floor out here. Make sure that there's nothing around like old rags, flammable liquids, what have you, to catch fire. Also, never solder on batteries, directly on the batteries, or other live circuits like house circuits. Make sure that anything is not active, it's not charged. The best you can do is damage the circuitry you're working on. The worst thing you can do is kill yourself. So no batteries, no live circuits. Again, these are the basics of soldering. If you're going to do soldering, I suggest you get on the internet, do some research, and implement the techniques that are appropriate to you and your type of soldering.